Hello, F Sharp. How are you doing? It has been a while, and there's been a lot of fun things going on, but I've been a little distracted with work. But thankfully, I've gotten back and been working on something that I've been excited to share with you. So one of the challenges that I have these days is we have our IDOS engine for my company. I work for Simulation Dynamics. We're a simulation and optimization company. We focus on supply chains, manufacturing facilities, and warehouses. And one of the things that we do is we model different types of phenomena. One of the types of things that we like to use is discrete rate simulation, which is a special kind of simulation. And we've been building out a custom engine for doing it that's faster than anything else in the industry. Well, turns out that the engine itself that does the actual computation of the simulation is now so fast that the slow part of our program actually ends up being taking the business domain model and then mapping that into the computational domain or the representation that we use for performing the simulation. Now, that translation that needs to happen takes advantage of read-only dictionaries. Also known as a frozen dictionary now, I believe, is coming in .NET 8. There's also the idea of static dictionary, but it's the idea of like I have a collection where I have this key value where I have data and I have keys that map to values, and I don't want it to change over time. I don't need to add or remove elements from it. So it's static or frozen or read-only. And this is a really useful thing, and you really want it to be as fast as possible. And so I decided like, hey, I want to go look at what is the performance of these different kind of key value collections that we might find in F Sharp, and to see if there's something interesting going on. Now, let me preface this with, since this channel is all about writing fast F Sharp code, my first recommendation is if there's any way you can turn your dictionary lookups into array lookups, do that. Absolutely do that, because an indexing into an array is 7 to 10 times faster than looking something up in a dictionary. And let me qualify that. I've done benchmarks before where I looked at indexing into an array using integer, and I compared that to the performance of looking up a value in a dictionary that is also indexed by integers, keyed by integers. And the dictionary was 7 to 10 times slower. And that's just using integers. So if there's any way you can turn that lookup into just an array indexing, please do that. Well, let's say you can't do that. And there are absolutely scenarios where you can't do that. And that's one that I'm dealing with. And so I need to make sure that, hey, this dictionary, this read-only dictionary that I am using is as fast as possible. And that's what I'm most concerned about with right now is the performance of just the read. So I don't really mind if there's a little bit more overhead with the creating of the read-only dictionary up front. I don't want it to be slow, but I'm making it once and then reading from it a bunch. So as I said, I went and looked at the common dictionary-like collections that you might find in F Sharp. And first of all, you have the F Sharp map, which is a key value collection, but it's not backed by a hash lookup. It's an AVL tree, and so it's going to have log in lookup time, which isn't terrible, but isn't great. But I wanted to include it in this comparison because you will likely come across it at some point. And then I also looked at dictionary, which is just the dictionary that's built into .NET that you would most likely be using. I also looked at read-only dictionary. The dict function in F Sharp allows you to take a sequence of key value pairs and turn that into an iDictionary instance. And also read-only dict, which is another built-in function. It's kind of a convenience function for taking a sequence of key values and then turning it into a iRead-only dictionary. So it's an interface that you're getting back. And what I wanted to do is I say, okay, I want to try keying by integers. And when you key with an integer is basically the best case scenario for lookup times, because when you do a lookup, you're typically hashing that value, mapping that hashed value to a bucket, and then doing an equality check. And it's like, hey, does this key match the key that's in here? And doing that with integers is as fast as it could possibly be on an x86 CPU, because all those things are single instructions or non-instructions, because the hash of an int is just the int. So it's like a 0-op. String is the other kind of key I wanted to use for my comparison. And string is basically the worst case scenario for a key for a dictionary, but it's also super common, which is, I understand why. And so you have to support it. And it is actually the scenario that I am dealing with the most here. But again, if you're trying to write something fast, as much as you can, get away from using strings as your keys for anything. But let's say we have to do it. So we'll do it. And so what I did is I said, hey, and you should be able to see here on the screen now, I have key type. I'm using benchmark.net. And I'm using two different key types. I have the integer key type and the string key type. And then I wanted to look at different sizes of collections, and that's what the key count column corresponds to. So this is instances where there's 10 keys in the collection, 100, 1,000, and 10,000. And what we should see is this should be essentially flat. In a perfect scenario, the mean time for lookup should be exactly the same. In reality, it's not, because you start running into cache issues, cache misses. And so it's the ideal. We shouldn't see logarithmic increases in speed, increases in time to look things up, but it should be relatively flat is what we're looking for, except for the F# map. That's an AVL tree, so we expect that to be going up log n. And so when I look at this baseline metrics that I ran, I found something really interesting. First of all, yes, F# map has this log n increase in time to look things up. Okay, so I went from F# map with 10 keys, 100, 1,000, and 10,000. And what's interesting is that, hey, we went from 1,000 to 10,000, but the time didn't really go up. Well, again, this is probably some cache behavior that we're seeing here, where stuff just happened to be in cache. But suffice to say, this is 10 times slower than any of the dictionary variants. So this is the difference between using an AVL tree and using some kind of hashing to an array scheme. And then when we look at strings, again, we see the kind of the logarithmic increase in time for the F# map. And again, relatively flat for all the dictionaries. This is what I found interesting, though. When I compare dictionary to the other versions, we see that all the other versions are slower. Read-only dictionary is slower, dict is slower, and read-only dict is slower. Now, dict and read-only dict being slower makes sense to me, because these are actually interfaces. And so when you go to do this lookup, the .NET code has to it has to go through the interface to figure out what is the concrete type behind the interface to do lookup. So I'm expecting there to be some additional overhead. So again, kind of expected behavior from what I'm seeing. This is actually the thing that really surprised me. It's dictionary versus read-only dictionary. And it's like, why is read-only dictionary got more overhead than dictionary? Well, from my understanding, the reason is because a read-only dictionary is a wrapper around a dictionary. And so when you're using a read-only dictionary, you're still adding another layer in between, you doing the lookup. It's got to go through the read-only dictionary method, then to the dictionary method, then it's actually looking stuff up. So you're adding additional overhead, additional lookups, additional cache misses here. That's really unfortunate because I'm pretty sure what I could do if I wanted to is I could write just a struct wrapper around dictionary and say, hey, inline all the methods on this thing so that I'm matching the performance of dictionary while only providing a read-only wrapper on top of it, I could do that. That would be the simple approach to this. And it's essentially what the types row and bar do over an array. You've probably heard me mention those at some point. It's my favorite wrappers for an array. Because everything about them is inlined, there's no performance hit for using them. So I could use a struct wrapper around dictionary, inline all the method calls, and get the same performance as dictionary, but a read-only wrapper around it. I could do that. But what ended up happening is I ended up doing some research on dictionaries, also known as hash tables, and I found a fascinating talk at CPPCon 2018. And I'm going to pull that up here real quick. Sorry, I should have had this ready when I started recording, but this should be real quick because I look it up all the time. Hash table. Let me bring this up real quick. Come on. Okay, this thing is gold. This talk, let me get in here a little bit so you can see the speaker. So, oh, come on, let's get a good picture of him. Oh, yeah. Okay, come on. Okay, here we are. I'm gonna pull this over. So this talk, C++, now 2018, you can do better than stood on a map. New improvements to hash table performance by Malt Shrupke. And my apologies ahead of time if I mispronounced that. But he gave this incredible talk about all these optimizations that he tested and validated of basically implementing a faster hash table. And so when I saw this, I said, you know what would be really fun? Taking some of these ideas and seeing if I could port them to F#. Like, how much could I actually bring over? Yeah, so that was a week ago. And I got lost. I was having such a good time. I put in a few hours on this one. So I'm pretty far behind on my anime now, but I know a lot more about writing a hash table, or also known as a dictionary. So this series is basically going to be me sharing all those learnings with you. And my desire is, by taking you through this experience of writing it, benchmarking it, profiling, it's going to help you develop some of that same intuition about, like, hey, how do I write a data structure that's highly optimized and very performant? And I will say up front, there are limitations about how far you can push things with F# and .NET. And that's fine. And it's one of those things I want to help you understand where the boundaries of the .NET framework are. Where are they? So that you don't slam into the same walls and get frustrated as I get sometimes. And I sincerely don't think we're giving up that much performance, but we can do better than the built-in .NET dictionary. And as a teaser, I just want to show you like where we're going to end up at the end of this. And so dictionary is the .NET dictionary, and bytelist Robinhood is the most optimized version of a read-only dictionary I was able to come up with. And we see for integers, it is almost twice as fast as the built-in dictionary. And for strings, we're getting like a 10-20% improvement. And we're going to dig into why that is the case. But still, we can go faster than the built-in .NET dictionary. And there's still some things I would like to try, but I've been delaying long enough. I want to share with you the stuff that I've been learning and hopefully get feedback from you. What would make me more excited than anything else is to have someone come in and say, Matthew, you've missed something completely obvious, and completely just blow me away with some incredible optimization that they're able to find. So that would absolutely delight me. Now, there's the intro to what the series is going to be about. Now what I want to do is to kind of walk you through the solution, the current solution as I have it right now, so that as I'm jumping around in code, you can see like, oh, this is where we're at and this is what we're working on. So now I'm switching to JetBrains Writer, which is what I'm going to be using for this. JetBrains Writer is actually my daily driver, what I use most of the time. I only use VS Code when I'm doing F# scripts or showing some stuff off. I love JetBrains Writer. I also love Visual Studio. I love VS Code and Ionide. I've been paying for all three of them for quite a while. So so we're going to be using Writer. So let's look at this solution here. We got the fast dictionary test, and that should give you a clue. When I started this, like, oh, this is going to be just an experiment. This isn't going to go very far. Oh my gosh. So inside of the fast dictionary test, we have this library, and inside of here is all the different versions of the read-only dictionary that we're going to play with and test. And you can see like, hey, we're going to start with a completely naive implementation. And by the end, we're doing this byteless Robinhood Vect 128 SIMD thing. So that's ultimately where we're going. And so each time we're going to kind of step through each of these and kind of peel back the layers of like, what's the justification behind this change? Like, why are we doing this? So you can understand, how to do this yourself when you want to implement your own dictionary or data structure. So this is where all the code is for the dictionaries. Inside of fast dictionary tests, I have unit tests for all these to make sure that my dictionaries are actually returning what they're supposed to be doing. And so let me zoom in here a little bit. My apologies. And so I didn't go so far as writing property-based tests. I probably should. Whatever. So I create some data, I create some expected values. And for each of these, I say like, hey, create an instance of my new dictionary and then iterate through all the key values and the expected values, look up the value, and I expect what I get back from my dictionary to be the same as what's in the .NET dictionary. And so I have unit tests for every single one of these. Oh, I got some dead code I need to delete. But yeah, so if you want to put in your own idea, and you want to crush my numbers and do far better than me, I would appreciate it if you would add it to the fast dictionary test, add a unit test here in fast dictionary test.tests, and then we can add it to benchmark. And benchmark is where I have all of the benchmark.net benchmarks. And I create a separate one for each one because to run all of the benchmarks, to run a benchmark of every single version would take just way too long. And let me show you what I'm doing here. At the top, I have different types of keys. I have struct key, ref key. In this case, I'm only using key types of int and string. So these aren't actually even used anymore. And then I have my key counts. And then what I do is I'm creating different data sets. So I have my int data set, and I'll have string data sets down below that I'm using for the testing. And then inside of each of these, what I do is I have the namespace for like, hey, these are all in the fast dictionary test.benchmark namespace. I have the name of the benchmark. So this is, I'm testing naive. I have my baseline dictionaries. So these are the .NET dictionaries that I'm going to compare against. And then I have my test dictionaries, and you can see here, like, hey, I'm creating the naive dictionary. And then I have benchmarks for the baseline dictionary, and then I have a benchmark for naive. And every single one of these here on the left is that thing again and again and again. And I'm using argue to pass in the arguments for like, hey, which benchmark do I actually want to run? And so if I come back here to the terminal and say like, hey, what is calling these benchmarks? What does that look like? In this case, what I'm doing is say, oh, I'm just going to escape, clear screen. So what I'm doing is a .NET run configuration release. Something that's important. This terminal is running an admin. And the reason it's doing that is because I want to be able to get the cache misses, branch instructions, and branch mispredictions. And you can only get that information if your terminal is running an admin. So noted. .NET run configuration release, and say, hey, what the task is, I want to benchmark and then the suite of benchmarks, and I give it the name. And if you want to figure out all the different suites, what I'm using here, if I go to match on benchmark, I have all different suites. So if it's baseline, naive, zero allocation, Fibonacci hashing, cache equality. So I'm basically just matching on these strings and saying, okay, which set of benchmarks am I going to run? So that's kind of like the lay of the land, what we're going to be doing. And we're going to just kind of step through each one. We're going to benchmark, we're going to profile, we're going to figure out what we can do to make it run faster. And we'll do that and see what it takes to get to that version that is even faster than the .NET dictionary. So thank you very much for joining me for the series. I hope you enjoy it. I hope you learn a lot. If you have questions, please feel free to ping me. I got an email, I got comments, wherever it is that you want to reach me, I'd love to respond. So thank you much for going on this journey with me. I hope you have a great time. Have a good one. Bye.